Hi, America here, back with another video, this time something a little bit longer than my previous videos. As you may notice, I did some C++ and made some short videos. And the reason I did some C++ is because of the problem I'm gonna talk about today. So what is the problem? Basically, I had a need for a border, but a border that is filled inside with basically with a color. Let's say we have a strategic map or some countries or whatever, and we want those countries to, well, have borders, but to have them colored. So let's say I'm gonna open a paint. So we have settlement here, settlement here, settlement here, a big settlement, I guess, and we have a border for the first, we have a second border for the second, and we have a third border for the third settlement. And the border itself is fairly easy to make with a spline. It's not a problem. You just take the length of the spline, take the step size, and spawn decals along the spline, and just color the decal in whatever color you want, and you have a nice border. But the problem comes in when we want to color the insides of those borders. So we want this to be colored, and this to be colored, and this to be colored as well. And I really didn't find anything online about this issue. I found one topic on Unreal forums that basically speaks about filling in a spline with static meshes. And I guess it was fine, but it really didn't have an answer, so I honestly had to come up with my own solution. And I did, thanks to a guy from YouTube that didn't speak specifically about this topic, but I used that info to my advantage and I used it to make my own system. I'm gonna link down in the description the video I found, thanks to whoever that made. I really don't remember the nick right now, the channel name, but it will be in the description. And I'm gonna talk a little bit about how it works, how I solve that issue. And it's gonna be on a high level, so I'm not gonna dive deep into the code. I did this both in blueprints. I first did this in blueprints, but I found that it's quite expensive, so I remade the whole thing in C++. So this video is just high level, but if you really would like to have a step-by-step guide on how to make such a system, just write a comment and I'm gonna probably make it in the future. In whatever you want, C++ or blueprints. But C++ are the way to go in this case, in my opinion, because blueprints are very expensive when it comes to loops, basically. And we have a lot of loops that we want to go through with that system. But I also made a second version of that system that doesn't require spawning a lot of points, a lot of checks, but instead it draws triangles to the decal. So I guess let's start. I don't know how long it passed, 4 minutes, okay. I'm gonna mark this point as start of the video. And let's see, what did we make? Maybe let's start with actual showcase. We have an actor, area actor, that is basically a decal and some splines. But if it of course works with just one spline, multiple splines, and you can make multiple actors with splines and mark it that way. But here is how the simulation works. We have some splines and we have points drawn to those splines. And we can change the position of those spline points. Let's say like this. And it checks those splines and draws points to them. So how does that work on a high level? Basically, we need a decal that is a base for drawing. It can be, of course, a big size like this, but we can decrease the size and it will just use that space to draw something. So in this case, it will just draw the inside of that decal and omit anything that's outside. The one downside is that it will draw some lines on the edges, so it's best to keep the splines inside the decal. So we have a decal. It has a pretty basic material. So just a color, a constant. It can also be a texture. And we have a mask. And we use that mask to fill basically areas of that decal that needs to be opaque. And the material itself is, of course, in the domain of decal, and the blend mode is translucent. And this is the version of this function in C++. I'm not gonna show you the code, but here's the version in Blueprints. It's a little bit longer. And the second material we need is actually a mask material. So I also made a mask that is a color. It has to be emissive because if it's base color, it will not be drawn to the render target. And the opacity mask, which is basically a radial gradient exponential. So you saw I drawn some circles, but we can change it to squares. So leave the opacity mask as none. It will draw squares, so something like that. And we can also make a gradient exponential with radius of, I guess, 1. And now the circles will connect and make some kind of a splash. Yeah, so something like that. And it's not very precise, but we'll come down to that later. Yeah, so it's just a mask. I'm leaving at 0.1 because I like the way it looks. I'm not gonna use it anyway because I use the trees in my project. So we have just an area filled with little dots. I think it looks very nice. And if we want to change the color, we can of course do that here, or leave it as a parameter and set the color in the blueprint itself. So first thing I do is take the decal, make a dynamic material instance, set it of course as a decal DMI so we can change it later, and set the decal material right here. And then I guess I am talking about C++ version, but maybe I should talk about Blueprint version because this doesn't really have a lot of nodes to in there, a lot of nodes in there. So let's talk about blueprints. First thing I do, after of course setting the DMI, is to set or get position of spline points so we can use them later. So I just take number of spline points, save them, make edges from them. So each edge is a vector 4 containing 2 points. And you may have noticed that I'm using vector 2D right here because we just want a 2D plane. We are not dealing with 3D space right now. So just 2D edges. We make a render target 2D. This basically means that we can draw to that render target. Well, we can draw to the texture at runtime or in the in-engine, whatever. It works just as well as an engine function. And we make its size to the decal size. Set texture parameter value as that render target to the mask, as you may have noticed. The mask is, well, where is the mask? Okay, this is the wrong this is the wrong material. We're of course talking about area decal. This is the mask parameter 2D, of course. So we set it as a parameter and we begin draw canvas to render target. Then we loop through those edges. We find if the points are in the polygon made from those edges, and if the point is in the spline, so in the polygon made from spline points, then we draw material to that canvas, which is a white mask. We draw white mask to that canvas. And if it of course can be a different material, you can use it in a different way, but in this case we are using mask to just, you know, mark areas visible. And then when we draw material and drawing materials to that canvas, we just said and draw canvas to render target, and it will display the drawn points. And I can, I guess, of course, talk about spawning static meshes, because you can use that system to spawn static meshes, but I don't think it's gonna be a very future-proof, because there is already a system in Unreal Engine 5.2 called PCG, Procedural Content Generation, that does this and more. So I don't think it will be useful, but if you want, you can include it in this system I made. So we have a draw debug line right here, but we can replace it with a line trace. Line trace by channel or whatever you want. It can be objects. And I am drawing an up vector from the point up because I want to see where the points are. Because sometimes it doesn't draw, but we want to see where the points are. So instead of that, you would raise the actor up a little bit so it doesn't touch the ground, and you would get a down vector. And down vector is, of course, up vector multiplied by -1. And this is a down vector, so we use this instead, right? So plug this into start, plug this into end, whatever, and on hit result, you can break it, get the location and spawn actor on that location. I'm not drawing, writing. Spawn actor from class, spawn transform 11000. Of course, rotation, you can do whatever you want with that. Location, and like that. Of course, we can check if there was a hit. So yeah, that's how you would fill the inside of the spline with static meshes. And if you were doing this, you probably wouldn't want to spawn an actor. Instead, you would have a static mesh, instance static mesh here as a component. Actually, we can add it. So you can see we have instance static mesh, and we just add instance at the location. That's what you would want to do, because this is much more expensive than this. You really, if you have the same mesh you want to spawn over and over again, you really want to use instances instead of separate actors. So I guess this is what you would want to make. And actually in this code we are transforming the local position to world position. So you would also want to mark world space here. So it takes world position in that instance static mesh. So yeah, that's the gist of my system. It works very nicely and works much more faster in C++. And the second version is to use trees. And what using trees does is, I mean, we still make edges. I use basically this in my C++. And with those edges, we make a polygon. A polygon is... actually, do we make a polygon? I mean, I know I am making a polygon here. And yeah, I'm checking it. But do we make a polygon here? I guess we're not quite doing it. We have edges, and edges as an array are a polygon, but we want to make separate polygons because we are drawing trees to the render target. Because render target, if you maybe don't know, has a few different options. First option is of course draw material, so you draw whatever texture you want to that canvas, but it has different options. Actually, that's the wrong. We want this node. So canvas, we want to draw to the canvas of the render target. We have different options like border, box, line, material, triangles, polygon text texture, and triangles. So triangles are in this case much more performant than drawing materials and checking if the point is on the polygon. We just draw triangles made from those edges. And how do we do that? We take, in the case of, let's say, this polygon, let's say this is the first point. We make these trees made of those 3 points. Then we make these trees made from those points. And we have 2 trees that make up this bigger polygon. So if we actually use draw debug lines and use trees, we can see that, oh, of course, I need to increase the decal size back to my original size that covers all of the spline points. We can see it used only the points and draw nice shapes with those splines to the render target. And that's actually the most performant way to fill a spline with color, but it also has a drawback. Actually, the whole system, not just the trees. The drawback is that it makes polygons from those points, and if you mark a point, I guess, curve, then it won't check that curve because it doesn't really have any way of knowing how that curve goes. It just takes points. But I guess if you are smart enough, you could take that curve into account, but I don't really think it's that necessary. But you could, I guess, if you really wanted to. I don't need it in my case. So another thing I want to talk about that is very cool is that the render target can be saved. The render target can be exported as a PNG. And then it basically is the most performant way. Like is the third way of doing this that is the most performant, more performant than the trees even. So what we can do is to draw stuff we want. We can even not use trees. And on completed, export that render target as a mask. And then on begin play, we can just use that mask. So how would that look like? We can do this in-game at runtime, or we can use it in editor. So this is my mask basically, but we can delete it, or maybe not. Let's use a second name. Area mask tutorial, so you know it works. And now we click this because I mark that event as calling editor. So we can just init render target. It spawn points, very nice. And we can import the second mask, which is made of points. Very nice. And now on begin play, we of course have a delay, so it doesn't spawn right up. We set the texture parameter value of that decal DMI parameter mask to the array mask. So we are not generating anything at runtime. We generate it at the engine level, and we just save it as a mask and use it in the project. And as you can see, it doesn't work. It didn't work because I actually don't know why it didn't work. I guess I didn't use the right mask, because we need an area mask that we made right now. And let's check this out right now. And it works. Nice. I was a little bit frightened that I did something wrong, but I did everything right. And yes, just didn't think of switching up the mask. So yeah. That's it. I hope you learned something. You can generate those masks at runtime, at engine level, whenever you want, and you can just use those refs or those PNGs in your game however you like. And I think it's a nice system that no one talked about really, and I think it's very, very useful. So I guess I already did a small tutorial with blueprints, but not so much, so the comment still stands. Like, if you want a tutorial, just write it down below and I'm gonna cover it in more details, the blueprint or the C++ version. And that's it. See you next time. Bye bye.